Now coming back to the SCS problem, we just already reviewed that how we have found the LCS. So let's try to find the LCS and solve this problem in the bottom-up approach and by using the 2D array. So just taking for this example, ABAC and CAB. Let's start. First of all, let's try to find the LCS, and then we will see that how to apply the second approach, the second algorithm step that we have reduced here. So I will create a 2D array for finding the LCS first. So str1, A, B, A, C, and then I put C, A, B here, and we end up with this terminal. I normally denote it by hash, and it should be always 0 because there's no common. It's null, right? There's no common LCS between this and ABC, AC. Like this is our base terminal condition. Now let's start using the formula. So if B and C, they don't match, here they're not matching here, then it should be the maximum of the next horizontal or the bottom of it. So it's 0 already, so it should be 0 again. Again for C and A, the same thing. C and A don't match, so it would be maximum between 0 and 0 is 0. Now here C and C are matching. Now we know that the formula for this is 1 plus whatever is the diagonal to it, the right diagonal bottom of it. It's 0, so it would be 1. Now let's fill the remaining cells. A and B don't match, it would be maximum of this. Now A and A match, it would be 1 plus 0, so it should be 1. A and C don't match, maximum of 1 and 1, which is 1. Now B and B match, 1 plus this, it's 1. B and A don't match, maximum of 1 and 1, 1. B and C don't match, maximum of 1 and 1, 1. B and A don't match, should be maximum of this and this, which is 1. Now A and A match, it should be 1 plus this, which is 2. And now we found A and C not matching, it should be maximum of 2 and 1 and 2. So this is the LCS of the str1 and str2. But here we can see that we are only finding the maximum length. We already found that the LCS is A and B, and the length is 2. So this formula only gives me the maximum length of the LCS found. But we can find the SCS by applying the second formula. Now that we have found the LCS, but we only found the length of the LCS. But now we also have to insert all the characters in the LCS, ensuring the order of characters in the original string. So this can be solved by just doing the bottom-up approach again. We have to see that how this value, if I just go from here and we have to move till down, then I need to see that where this 2 number came from. So here we found that this 2 number is found because C and A, they are not matching, right? So we found that it should be the maximum of the next horizontal cell or the below cell. So it means that, and now we can see that it is coming from the horizontal cell from 2. So so here the algorithm says that if this number is derived from the column cell, from this horizontal cell, it means that we have to extract or keep on getting these numbers from exhaust the strings from the column. If it was like matching, then we will see that we have that how to proceed with that. But this is how we actually have to approach from that. If we found that this number is achieved from horizontal or bottom, we have to move across that. So it means that we have found this cell, and now we have got this from this 2, not from the bottom, because this is how this 2 cell came from. It came from this number. So it means that we have to take this character from here. not here, because we are still at A. So C, I can mark it as C, that we have already exhausted this. And now let's go here. Now we found that A and A both are matching. So it means that we know that this number has been formed from this diagonal cell. That is 1 plus whatever has been in the diagonal cell. So we move here. So we move from 2 to 2 and then from 2 to 1. And because we are moving this side, which means that we have already used A and A. That's why we are left with B and BAC. That's why, and this corresponds to this cell, right? So we have to exhaust both A and A, which is common to it. So we only need to let it to 1. So as soon as I'm exhausting, I'm changing it to red. So we have already exhausted A here, which is common. And now we move here. Now we are left with B and BAC. Again, for B, we see that it's matching, right? B and B are matching. So it means that this cell came from this diagonal cell. So I'll mark it as again 1 plus the diagonal cell here. And because B and B both are common, so I will just put it once in our SCS solution. Now it's B. Now we have already exhausted C, A, and B, and there are no characters left in the STR2, which is CAB. And we are only left with 2 characters here, A and C, from the STR1. So we have to exhaust all this, and then A and C, and we just simply put it in the same order as there in the STR1. So this is our final solution. So let's revise it again. First of all, we calculate the LCS in the same way as we have done it before in our previous tutorials. We create this 2D array and we form this grid, and then we start from the bottom approach. We see that if the characters are not matching, in that case, we will see that how this number came from, whether it's from horizontal or whether it's from vertical, from down. And here we found that it's from horizontal. It means that we have to exhaust the character from the STR2, which is in the column side, because we have already consumed it and we placed it here. And then the other scenario is that if the characters are matching, in that case, we know that it has come from the diagonal 1 plus whatever has been in the diagonal LCS between BAC and B. That's why we move down and we exhaust or we extract both the characters from both the strings and place it here. By doing this formula, we found that at this position, we have already exhausted everything from STR2, from the columns. That's why we simply took all those remaining characters from STR1 and place it here.